All right, so we're moving forward here, and we're going to look at lesson 4 here, which starts on page 155 in your workbook. You just did the exploration in Desmos to kind of discover some of these angle relationships, all right, with two lines and a transversal. All right, you can see with our standard right here, I can identify and find their measures, and we're going to spend time today doing just that second part. They're finding their measures. But before we get to that today, once again, a little opener activity here for you. So using this diagram, all right, go ahead and answer those 6 questions. Pause the video, do that, and then turn it back on, and we'll go from there. All right, so that does look like an arrow above there. So I know it's a little hard to see here, but that is line BD. And remember, we just need any 2 points on this line. All right, so we could have done AD, right? We could have done BC, we could have done AC. So any 2 points on this line would do. Whereas when we look at EG, all right, there's only one other way to name EG, because EG is specifically from E to G. So the only thing you could have done is just reverse, all right, and still put the segment over the top of it. All right, and then now notice we have CH. I believe that is a ray. It's a little hard to see. All right, and there's really not another way to begin CH, right? Okay, all right, because C, it starts at C, so we have to, excuse me, begin with C every time. Now, notice as we go through H, we could also go through G, and that means the same thing, right? So I'm going to start at C, and I'm going to go, all right, that way. Okay, name all segments with endpoint B. That's a lot, right? So we could do AB, BA, BC, CB, BD, DB. So there's a lot of different segments with an endpoint of B, right? All right, so there's just one. Name one pair of opposite rays. All right, so I'm just going to go, we could do BA, and then I could go BC, right? So I could go B to A, B to C, and that creates line AC, correct? And then name a point on AC. So any point on this line right here would do. So let's say B, C, A, or D. All right, so there's just a quick review of some vocabulary, some notation things, just to kind of keep it fresh in your mind. All right, so let's go ahead and flip, all right, over to page 156 here, and let's look at our diagrams here. So once again, I'm just going to go through real quick, and I'm going to highlight our transversal. I'm going to use pink this round. So I'm going to just do that in all of our pictures here. And then hopefully, all right, this kind of solidifies what you did, all right, with, all right, the Desmos activity. So now, once again, I'm just going to put our angles in here. So if you need to pause the video to do that, please go ahead and do so. All right, so let me just fill those in real quick so we all can talk about the same things here. All right, and then what we want you to understand is that you can always identify the types of angles. So whether we have parallel lines or not, you can always identify the types of angles. What changes is whether we can say that there is a relationship that exists. All right, so let's start with, all right, corresponding angles. All right, so notice we can still identify. So 1 and 5 are corresponding, 1 and 5 are corresponding. Okay, 2 and 6, 2 and 6. All right, so identify them doesn't change. All right, now what you can't see here, that's kind of hard to see here, is relationship if the lines are parallel. And then if the lines are parallel, what we know is that corresponding angles will always be congruent. All right, so these will be congruent. All right, so for example, angle 1 would be congruent to angle 5, right? And all pairs of congruent, or excuse me, corresponding angles will be congruent. Okay, so now let's go to alternate interior angles. All right, so once again, we can identify them. So 2 and 7, 4 and 5, those are alternate interior angles. Well, when the lines become parallel, they are still alternate interior angles, so we can still identify them. But now what happens is, once these lines are parallel, all right, alternate interior angles will also be congruent. So these will also be congruent. All right, so angle 2 would be congruent to angle 7, and angle 4 would be congruent to angle 5. And then if we move on to alternate alternate. All right, exterior angles. My brain froze up there for a second, even though I just wrote alternate right above there. So once again, we can identify. So 1 and 8 are alternate, 3 and 6 are alternate. Even with parallel lines, 1 and 8 and 3 and 6 are still alternate exterior angles. But now, once again, when those lines are parallel, a relationship occurs, right? And these will also be congruent. All right, and so angle 1 would be congruent to angle 8, and angle 3 would be congruent to angle 6. All right, now, same side interior angles has a different, all right, type of relationship here. So once again, we can still identify them, 2 and 5, 4 and 7. Parallel lines, still 2 and 5 and 4 and 7. All right, now, what is going to happen here is now our same side interior angles will be supplementary. All right, so that means the measure of angle 2 plus the measure of angle 5 would equal to 180. The measure of angle 4 plus the measure of angle 7 would also be 180 degrees. And the same is actually true for same side exterior angles, but for some reason that's never really used much in geometry. Not really sure why, but we don't really use same side exterior angles as much. So anyhow, those are your 4 relationships that will always happen. All right. So now when you think about alliteration, right? So same side are supplementary, right? All right, same side supplementary. So just think about all those, all right, alliterations, all right? Marvel is famous for that, right? All the different people there, all right, with, J. Jonathan, right? Peter Parker, all the different names, right, that start with, all right, the same letters. Okay, so now let's just move on and do some examples. So let's flip to page 157. 157, all right? Okay, now, all right, so once again, the relationship is dictated by 2 things, what transversal you're on and if you intersect parallel lines. So notice in this example right here, it tells us that C is parallel to R. All right, so C is parallel to R. So these are our parallel lines. Okay. All right, so only the pairs of angles that are touching those 2 parallel lines will have those relationships we just identified. All right, so now if we look at, all right, okay, what we have here. Okay, so we have 2 different transversals that hit our 2 parallel lines, right? So we have O and we have W. So now we have angle 4 and angle 16. So when I find 4 and 16, okay, so I'm on this transversal here. All right, and I'll highlight this one as green here. So when we look at this, okay, so the first thing is when I look at, and this didn't really show up much there. Let me try it again. There we go. All right, so now the first thing is, all right, let's see if we can identify the types of angles. So when I look, all right, 4 and 16 are in the bottom left and bottom left. So that means that they are corresponding angles. And the second question is, okay, all right, do we intersect the parallel lines? And if we do, we know corresponding angles are congruent. So notice I do intersect our parallel lines here. So that means that 4 and 16 would be congruent. All right, so if 4 is 112, that means 16 also has to be 112. All right, okay, and I guess I could have put it right here. All right, there you go. All right, so it's important, right? You have to identify them, and then the question is, okay, do they intersect the parallel lines? Okay, so now let's look at 5 and 11 here. All right, so now 5 and 11 are on this transversal here. All right, so I'm going to go through and highlight this one as pink here. All right, so now when we look at 5 and 11, remember we can always identify angles, okay? So when I look at this, 5 and 11 are alternate and exterior, all right, as we cross those lines. Now the next question is, okay, do they intersect, or do we intersect the 2 parallel lines as we drive down W here? And the answer is yes. So that means then alternate exterior angles are congruent. So if 5 is 65, that means 11 also has to be 65. All right, so now let's move to number 4 here. All right, we have angle 3 is 71, and we want to know about angle 8. So now here's 3 and here's 8. Okay, here's 3 and 8. Now notice our transversal is one of the parallel lines. Okay, so this is R. But notice we can still identify here. 3 and 8 are same side interior angles. Okay, that will never change. Okay, so we can always identify them. Now the question is, okay, do we intersect two parallel lines? And notice what it tells us, that O is not parallel to W. All right, so the two lines that we intersect here are not parallel. All right, and because they're not parallel, we can't do anything more than just identify them. All right, so that would be there is not enough information to answer that question. Okay, so we have to know the two lines we intersect are parallel to assume the relationships we just identified on page 156. All right, now let's move to number 5 here. We have 7 is 55. We want to know about 10. So here is 7 and 10. All right, so once again, we can identify these. All right, these are same side interior angles. Now the question is, are we intersecting parallel lines to identify that relationship? And the answer is yes. So 7 and 10 are same side interior angles. We intersect parallel lines, so we know 7 and 10 are supplementary. So that means they have to add to be 180 degrees. So if 7 is 55, that means 10 has to be 125. All right, my friends. So that is it for our video. So you can go ahead and finish problem 2. All right, and I think that's it. All right, and I will see you guys next time.